If you searched Build AI Agent, here's the answer in one sentence. You need three components: a large language model as the brain, tools the agent can call, and a framework like LangChain or CrewAI to orchestrate the decision-making loop. In the next 9 minutes, I'll walk you through building a working AI agent from scratch, whether you code or prefer no-code solutions. By the end of this video, you will have a complete understanding of agent architecture, framework options, and a step-by-step build process you can follow today. Let's get started. So, why build AI agents right now? According to Gartner's 25 report, 33% of enterprise software applications will include agentic AI by 28, up from less than 1% in 24. McKinsey estimates that autonomous agents could unlock $4.4 trillion in annual economic value across industries. The agent market is exploding because these systems don't just answer questions, they take action. An AI agent is fundamentally different from a chatbot. A chatbot responds to prompts. An agent perceives its environment, makes decisions, and takes actions autonomously to achieve a goal. Think of it like this. ChatGPT is a librarian who answers questions. An AI agent is an assistant who reads your email, schedules meetings, researches topics, and drafts responses without you asking each time. The key difference is the reasoning loop. Agents use a cycle called react, reasoning and acting. The model thinks about what to do, selects a tool, executes it, observes the result, and decides the next step. This loop continues until the goal is achieved. A Stanford study in 24 showed that GPT-4-powered agents using React loops solved complex tasks with 73% accuracy compared to 34% for direct prompting. The architecture matters. Every AI agent has three core components. First, the LLM brain. Models like GPT-4, Claude 3.5 Sonnet, or Gemini Pro serve as the reasoning engine. The model receives observations, plans actions, and generates tool calls. Second, the tool layer. These are functions your agent can call. APIs for web search, database queries, calculators, file systems, or custom business logic. When the agent needs information it doesn't have, it calls a tool and receives structured output. Third, the orchestration framework. This is the control system that manages the reasoning loop, handles tool execution, manages conversation memory, and implements safety guardrails. Popular options include LangChain, Llama Index, CrewAI, and AutoGPT. The orchestration layer is crucial. It prevents infinite loops, manages token budgets, implements retry logic, and ensures your agent doesn't hallucinate tool calls that don't exist. Let's compare the main frameworks to help you choose. LangChain is the most mature, with over 80,000 GitHub stars. It's Python and JavaScript based, offers the most integrations, and has extensive documentation. Best for developers who want maximum control and flexibility. CrewAI is newer, but purpose-built for multi-agent systems. If you want multiple specialized agents collaborating, like a researcher agent, writer agent, and editor agent working together, CrewAI handles that coordination elegantly. It has 15,000 stars and growing fast. Llama Index excels at building agents that work with your own data. If you need an agent that queries documents, databases, or knowledge bases, Llama Index's retrieval augmented generation architecture is optimized for that. It has 28,000 stars. For no-code builders, platforms like Relevancy AI, Stack AI, and N8N offer visual agent builders. You drag and drop components, connect APIs, and deploy without writing code. Relevance. AI reported that non-technical users build functional agents in under 30 minutes on average. My recommendation, if you're a developer learning agents, start with LangChain. It's the industry standard and the skills transfer everywhere. If you're non-technical, start with Relevancy AI or N8N. You'll have a working agent today. Let's build a research agent step by step. This agent will take a topic, search the web, summarize findings, and save a report. I'll show both code and no-code approaches. First, define the goal clearly. Our agent's objective. Given a topic, research it using web search, synthesize 3 key insights, and save them to a text file. Clear goals prevent scope creep and infinite loops. Step 1. Choose your LLM. We'll use OpenAI's GPT-4 Turbo for this example. You need an API key, Sign up at platform openai.com. Cost is about 2 cents per agent run for this use case, based on typical token usage. Step 2. Define your tools. Our agent needs 2 tools, a web search function and a file write function. In LangChain, tools are Python functions decorated with a description. The description is critical. It tells the LLM when to use the tool. For web search, we'll use the Tavily API. It's designed for LLM agents and returns clean, structured results. Alternative, Serper API or Brave Search API. All cost under a penny per search. For file writing, we'll use a simple Python function that writes to the local file system. In production, you'd write to cloud storage like S3, but local files work for learning. Step 3. Initialize the agent. In LangChain, you create an agent executor that combines the LLM, tools, and agent type. The agent type determines the reasoning strategy. We'll use OpenAI functions, which uses GPT-4's native function calling. Step 4. Add memory. Agents need memory to track what they've done. LangChain's conversation buffer. Memory stores the chat history. Without memory, your agent forgets previous steps and may repeat work. Step 5. Run the agent. You pass the goal as a text prompt. The agent enters the React loop. It will think, search, read results, think again, and write the file. You'll see each step logged in real time. For no-code builders, the same process works in N8N. Add an AI agent node, connect an OpenAI credentials node, add a Tavily search tool node, add a write file node, and configure the goal in the agent settings. Hit execute. The entire code version is about 50 lines of Python. The no-code version takes 5 minutes to configure. Both produce the same result, a working autonomous research agent. Testing agents is different from testing normal software. Agents are non-deterministic. They may take different paths to the same goal. Your testing strategy should focus on outcomes, not exact steps. First, test edge cases. What happens if search returns no results? What if the LLM hallucinates a tool that doesn't exist? What if the task is impossible? Good frameworks handle these gracefully with retries and fallbacks, but you must test them. Second, implement guardrails. Set maximum iterations, typically 10 to 15 steps, to prevent infinite loops. Set token budgets to control costs. An unconstrained agent can rack up hundreds of dollars in API calls if it gets stuck. Third, add observability. Use Langsmith or Helicone to log every agent run, track costs, and debug failures. According to LangChain, 68% of agent failures are due to poor tool descriptions or ambiguous goals. Logging helps you identify these. For deployment, simple agents run as scheduled jobs or API endpoints. Wrap your agent in a Flask API, deploy to a platform like Railway or Render, and call it via HTTP. More complex agents run as background workers processing queues. Production checklist. Error handling, retry logic, cost limits, logging, output validation, and human-in-the-loop approvals for high-stakes actions. An agent that can delete data or spend money should require human confirmation. So, here's my concrete recommendation. If you're a developer, spend this week building 3 simple agents. A research agent like we built, a data analysis agent that queries a database, and a content agent that drafts emails or posts. Use LangChain. You'll understand the patterns deeply. If you're non-technical, start with a single task agent in Relevance AI. Build something you need, a lead enrichment agent, a customer support triage agent, or a content summarizer. Use a template, customize it, and deploy it. The fastest way to learn is to use your own agent daily. The agent space is moving incredibly fast. New frameworks launch monthly, models improve reasoning every quarter, and tool ecosystems expand constantly. The fundamentals we covered, LLM brain, tools, orchestration loop, will remain constant even as specific technologies evolve. Common mistakes to avoid. Vague goals lead to confused agents. Too many tools overwhelm the model's decision-making. No memory causes repeated work. Missing guardrails cause runaway costs. Keep it simple at first. 1 goal, 3 tools maximum, clear success criteria. If this answered your question, subscribe. We cover AI tools and news every week. If you found this useful, don't forget to hit the hype button. It helps the channel grow.